On Earth, networks are ubiquitous. From humans socializing with one another, to rivers and streams branching out like veins, or even a spider making its nest by webbing a tree. Networks are any series of connected devices that are capable of communication. But what is a network made out of? How does data transfer through the internet? What do stuff like IP, HTTPS all mean? First, we need to explore the most important devices in a network: the host, switches, and routers. Hosts are devices that can start and receive communication. This includes your computer, phones, and tablets. To connect hosts together to make a network, we use a switch. Up to 254 hosts can be connected to a single switch. If two hosts in this network want to communicate, the data will be sent to the switch to be directed to the correct host. Lastly, to connect different networks together to create a bigger network, we have to use a router. Notice how the switch connects different hosts, and router connects different networks. That's how they're different. A crazy thing is, routers can be connected to multiple other routers to make an even bigger network as well. With multiple routers connected to each other like that, every device in the world can all be connected together nowadays. That's why it's called the internet. Now, how does data get transferred over the internet? Well, first, the data you send are split into different data packets. Data packets have two parts: the payload, which is the actual data being sent, and the header, which contains extra information like its source and destination. Each packet also needs a protocol, which is the rules used to transfer that data packet. Data packets are transferred through the 7 layers of the OSI model, which is the conceptual framework of network communication. Though in real life, these top 3 layers are merged together into one most of the time. This is called the updated TCP/IP model. Let's explore what each of these layers does. The physical layer transfers bits, which are zeros and ones, between network devices. This includes wires, cables, Wi-Fi, and Bluetooth. The data link layer interacts with how the physical layer transfers bits. This is basically what the switch does, directing data transfer from a host to another. There's also the MAC address, but we'll look into that later. The network layer is responsible for the routing inside the network. This is done by the router, and sometimes the switch as well. This layer has a lot to do with the IP address. Now, most of the network devices we mentioned earlier both have an IP address and a MAC address. But why do we need two addresses? When two hosts communicate, the source and destination IP addresses are usually provided by the user. But we don't know the MAC address of the router or switch that can direct our data into the right host. In other words, MAC address is the journey, and IP address is the destination. To resolve this, they have to broadcast an ARP request to every device in that network to find the host with the IP address and return back with the requested MAC address. The transport layer focuses on the way data is transferred through a network. There are 2 protocols to transfer data through a network. UDP is quick, but TCP is significantly more reliable. With the demand for data integrity nowadays, right now people mainly just use TCP. The transport layer also has to do with ports, which are like mailboxes, the YT station, or the YMI wardrobe. It represents the gate in which the two hosts are connected, and kind of the service you want in the final layer, the application layer. For example, the DNS converts your web links into target IP addresses. Websites use HTTP or HTTPS. Email uses SMTP, POP, or IMAP. And lastly, file transfers use FTP. In summary, in this video, we've learned about the fundamentals of networks. That includes the network devices and the 5 layers in the TCP/IP model. Thank you for watching our video. And until next time, farewell.